So we're just kind of talk generally about match pairs tests. Here's how they look. You have two sets of observations measuring the same response variable, and they come in pairs, and the pairs aren't independent. So each x is, the first x is related to the first y, the second x related to the second y some way. Ordinarily because it's the same person or same object, or because you found a way to match them up according to some other variable. And so what that does in theory is it makes these values dependent on the pair, but the difference then would be dependent on the treatment. That's the idea. Often we are comparing treatments to placebo, where we have matched subjects to make them as similar as possible. So whichever way you can think to make them similar. The best way to make them similar is having them be the same person. But if you're comparing like weight loss strategies, you can't have the person do both weight loss strategies very effectively. And so you basically have to try to match up your subjects according to how easy you think it is for them to lose weight, and then put them in the two treatment groups. Okay, so that's just that. How does it work? We consider the differences. DI is xi minus yi. We set up a hypothesis test. The null hypothesis is the mean. Long-term mean of those differences is some number, and the alternative is one of the three kinds. Often the null hypothesis is 0, or mean is 0, because we're trying to detect a change. So if the treatment had no impact, then the long-term mean of the difference between the treatment group and the placebo group should be 0. And we could see if it is or not by putting 0 here and seeing if we can't reject that null hypothesis. We go ahead and do that, compute the p-values, declaring the results statistically significant if the p-value is less than 0.05. And then we're going to have to check some conditions. The conditions we need for t is a large sample size, 30 or approximately 30, maybe 40, or an approximate normal distribution according to the sample. So we take the sample and do a normal probability plot, see if it seems to be approximately normal, and then we can deal with a smaller sample size knowing that. We also need simple random sampling, or some kind of random sampling that imitates simple random sampling, and the sample much smaller than the population. All these things are necessary for the D bar. Oh, I call it D bar now, D for difference. Oh, there you are, Ds. Where they're up there, Ds, yeah. They're needed so that D bar has a normal distribution, and that allows us to compute T here, and the tables which should give us a value of T and we can look up probabilities if we had stuck the right number here. So the null hypothesis allows us to compute the type 1 error probability, the probability of rejecting, which we say is 0.05 here, if the null hypothesis is true. So we don't want to reject the null hypothesis when it's true. We try to make that small. We keep it at least as small as 0.05. We often also construct a confidence interval if the null hypothesis is rejected. It doesn't make a lot of sense if it's not rejected. But if it is rejected, you might wonder, where is that mean actually? I know it's not the quoted mean. Where is it? So let's see if we can get that done on the next example. So here we go. Example 2. An experiment investigated whether eating oat bran lowered serum cholesterol levels. 14 individuals were randomly assigned a diet that included either oat bran or cornflakes. I want to be in the cornflake group, I said. I don't like oat bran. Too bad. They're randomly assigned to oat bran or cornflakes. You don't get to let them pick, because people might choose a diet, and the choice of diet might also impact other things they do with their diet, which might impact their cholesterol levels. So we don't want to let them pick their own breakfast. After 2 weeks on the initial diet, serum cholesterol were measured, and the participants were then crossed over to the alternate diet. After 2 weeks on the second diet, cholesterol levels were once again recorded. So here's a situation where each person serves as his own match. Why would you do that? Well, because people might tend to have high cholesterol or low cholesterol, and all you're measuring is the level. If you measure in the oat bran case and in the cornflake case separately, and then you take the difference, you can see whether oat bran seems to lower cholesterol. And then half the time they start with oat bran, half the time they start with cornflakes. That's convenient for the experiment, but also tries to eliminate the fact that maybe when you're in the experiment over time, the cholesterol level goes down because you're more careful what you eat because you know things are being measured. And so that's something that might happen. And so if we make sure half the people start with oat bran and half the people start with cornflakes, then you've got people that are they're eating oat bran second. And if the cholesterol level is going down because of time, you have also people eating cornflakes second to kind of balance that out. So that was a pretty well-designed experiment. It says here, the data appears below. The variable cornflake in the table represents cholesterol level of participants on the cornflake diet. I stole this from somewhere. I think these numbers are legitimate. The variable oat bran represents the participants' cholesterol level on the oat bran diet. Same person. Cornflakes, oat bran. We didn't keep track of which came first. Some of them had oat bran first, some of them had cornflakes first. We don't know which is which here. Why do you think they were assigned the diets in random order? And that was because being in the experiment might lower your cholesterol level. And so you have them split, half oat bran, half cornflakes beginning, and half oat bran, half cornflakes at the end. And so that tendency then will be canceled out. And my phone is ringing. This is a great day. Let's see how this works. Hello? I can't talk to you on my class. Okay, bye. Okay, well, it wasn't the president of the US, so I shouldn't have picked it up, but I thought it was. Why not just randomly assign subjects to one of the two diets and record the results? Well, because they might just have high cholesterol, and you'd have to measure them before and after. You might be able to do that. Measure the cholesterol level, then put them on the two diets and see what happens. That could work. Once again, they would be then serving as their own match. On the other hand, because they're in an experiment, maybe the experiment, they pay more attention to what they eat, and that they're over time, their cholesterol level might go down by accident because they're being more careful, and it would look like the diets are working. Here, I think we have the ability to get rid of that impact because we've had them assign cornflakes or oat bran in either order. So that idea that they might just lower their cholesterol because they're in an experiment would be equally applied to the oat bran people and the cornflake people. So we could cancel that out. So I think that works. And okay, let's do it though. Oh, we have to do work. Oh dear. Okay, well, I guess I'm going to go to work. This won't be fun. That's a lot of numbers to type. But I guess we can handle it. All right, here we go. How about turning it on? There we go. Clear, stat somewhere, edit, go up there, clear that. Come over here, clear that. Okay. And then we're going to go here, 4.61. I should have not had so many decimal places, but this is how this information came to me. I'm notorious for typing wrong. I still did it wrong. 3.82. There we go. Okay, so I'm just going to take a quick look here. Do you see any bad numbers? Going to the top. Okay, 61, 42, 54. I think we're okay. Okay, I'm coming across. Okay, I'm sort of scanning those. Still looking. I think we're okay. So I'm going to go over here to list 3. I'm going to clear that. And I'm going to store the differences in list 3. So which one do you want to do? Do you want to do cornflakes minus oat bran? And then we're trying to look for a positive number? That makes sense? So this is cholesterol. We want it to be lowered, right? So we want this minus that to be positive. So we'll do this. We'll do cornflake minus. Okay, so I'm going to quit here. I'm going to do cornflake, which is list 1. I'll go second 1, subtract off second 2, and then the store button is down here. Store that, and I go second 3 to get list 3. So that'll automatically subtract these theoretically larger numbers from these theoretically better numbers, and then a big enough positive value for X bar is going to tell us that it worked. Okay, did that.
How did you get the store value, like the arrow?
This guy here, next to the 1.
Do you mind lifting it up a little bit? I couldn't see it. Oh, okay, got it. Thank you.
Okay.
How did you get to that screen as well? Like the L1 minus L2.
So we'll go like this. You go second, and you hit 1, and that brings up list 1. You see that little blue list 1 on top of the 1? Just to the tip of my finger there.
Yeah, I got it.
So you get those. That's how you get the list to show up on the screen. And then you could do arithmetic with them like we did. And that'll subtract all the list 1 numbers from the list 2. So, sorry, subtract list 2 from list 1. And then we hit the store button, which was down here next to the 1. Makes that crazy arrow. And it goes second 3 to get list 3. So it takes list 1 minus list 2 and stores it in list 3. I'm going to do it again. I won't do any damage. It did it. And I'm going to come back and look at it. I always like looking at it to see what it did. So list 3 has those differences. We see they're mostly positive numbers. That makes me feel good. That makes it look like the treatment might be working. Oat bran seems to do better than cornflakes. We think cornflakes don't do anything. It's like the placebo group. You're chewing and stuff, and maybe that impacts your cholesterol level. Who knows? Maybe just even having breakfast might influence your cholesterol level. So we have to make sure they have something similar to oat bran to have. And then I'm going to go stat, calc, one variable there. And I do list 3. So second 3. Let me list 3. Now I know everything about list 3. List 3 is the differences. All right, so we're in business, I think. Let me write it down. I'm going to put it somewhere. Maybe I can put it on the next page, see what the next page looks like. I'm trying to figure out where we are. I seem to have, I'm working my way backwards in time here. Where's the future? I've already done all this. Oh, here we go. Okay. This might be the end of the day. Yep, we're going to try to do it all. Okay, let's set up the test. Well, I've already done the calculations. Usually you don't do that first, but fine. So H naught was, we're thinking the mean of the differences is 0. That says the treatment had no impact. And H1 says, I'm thinking the mean of the differences is actually bigger than 0. That means the treatment had an impact. We're going to compute T. It's going to be D bar, if you want to call it that, minus mu D. Oh, we've got the standard deviation. I guess like this over root n. I guess we'll do that. Okay. And X bar was 0.3628. Minus 0. The standard deviation is 0.4059. So what, 406? I'm gonna go 406. 0.406 over the square root of the 14. So we had 14 pairs, so we have 14 differences. So we're gonna use n equals 14. And of course I could ask my calculator to do this, but first I'm gonna compute it myself just for fun. So I'll clear that. 0.3628 divided by parentheses 0.406 divided by square root 14, come over, close that. Well, 3.34. We know something about that. That's a big number. So those differences, this 3628 is meaningful. It's not just random variation. It might not be meaningful in a health setting. That tiny change in cholesterol levels might not cause you to be any healthier. So whether it's practically of any significance, sure, oat bran lowered cholesterol a tiny bit. Was that tiny bit enough that you want to eat oat bran? That's something a doctor can answer. A statistician just says, this looks like it wasn't random variation. The oat bran seems to have a treatment effect, but it might be minor. And I'll ask the calculator to do it right now because I have to. Okay, so we'll go back to stat here. We'll go over to tests. We'll do a t-test. And then we're going to use data. The null hypothesis mean is 0. We're in list 3, second 3. And we're thinking we want to check to see if the new mean is bigger than 0. Pick that. Everybody with me? I'm going to hit enter. It'll do it now. So there's the t-value. It matches us. Here's the p-value, which we're going to try to confirm in a minute. The p-value is 0.0026. We'll only get an approximate answer. Okay. So we're going to check assumptions. We need to check normality of the differences. We're not too worried because n is 14. Normal, I suppose there's a t there. Yeah. 14 is a reasonably big number. We don't want to see anything too crazy. I'm going to go to stat plot, second stat plot. I'm going to go down to plot 1, go in there, make sure it's on. Okay, the type is over here. That's the normal probability plot. I want to use list 3 is where my stuff is. Everything else I don't care about. Okay. And we did all that and nothing happens, of course, because you have to graph it. There might be stuff in the graph window already. We might have to get rid of it. Here's the graph window. We'll zoom down to stat, see whether it can do anything. There we go. So that's reasonably straight. Pretty happy, all except this one value is a little bit smaller than you might think. This is the largest value. Like this is the data axis here, I think. So that corresponds to, there are 2 big numbers, but that's no big deal. So it's pretty much a straight line. Did that. Check. We want to check a simple random sampling. So are these a random sample that people would have high cholesterol, or they were collected for some other reason? If they happen to be involved in some other study, then there might be a problem because things might be changing, not because of the oat bran. So we want to make sure we just chose some subjects randomly and then assign them the 2 treatments in this fancy way. Provide a p-value, got it. Let's look at the tables now. So the degrees of freedom, I wonder if it says it here. We'll go back here. We'll get out of here. We'll go into stat tests. We'll take the t-test. It's all ready to go. So it just gives you n. It doesn't tell you degrees of freedom. That's interesting. So degree of freedom is 1 less. 14 minus 1 is 13. Here's our value, 3.34. On the tables, we said 13. I'm looking for 3.34. Zooming around here. Okay, so there we are. 3.34. Oh, 3.34. It's bigger than 3.3. So it's between here and here. So the tail probability is between the two numbers on top, 0025 and 001. We'll check that. Between 0025 and 001. I don't know. Is that really right? Was it 13? 3.3. No, 3.34. It's back here.
It should be 0.005 and 0.0025, right?
I think that's right. So it's slightly bigger than 0025, which it is. 0026. I think we're good. Yep. Draw conclusions. Oat bran seems to reduce the cholesterol level we need a confidence interval to determine how much. I can't write how much, that's funny. So we're going to make a confidence interval for the mean decrease. The decrease was about 0.3628. Looking at the numbers, it looks like that's not that meaningful. It could be. Sometimes small changes in values in blood work are meaningful. So we'll find out in a second. I'm going to stop sharing right now so I can break this up. Or stop recording, pardon me.